6.5 notes, we're going to talk about rhombi and squares. So first are some properties of a rhombus. And a rhombus is a parallelogram with all four sides congruent. And a rhombus has all the properties of a parallelogram then, obviously, along with two additional ones. Those being that in a rhombus, the diagonals are perpendicular. So remember that means they form a right angle. And if it's a rhombus, then each diagonal bisects a pair of opposite angles. So if you're looking at this picture here, this diagonal RP would bisect angle 1 and 2. So angle 1 and 2 would be congruent. And actually, those would be the same as angle 3 and 4. And here's why. Because if you're looking at this rhombus, all four sides are congruent. So if you look at just these two sides, we have an isosceles triangle. And remember that in an isosceles triangle, the base angles are congruent. So 1 and 2 would actually be congruent to 3 and 4. And then also the same is true, 5 and 6 would be congruent to 7 and 8. And a reason for this would be alternate interior angles. If I draw in that Z, those angles inside the Z there have to be congruent. So since you know 5 and 6 are congruent, if 6 is congruent to 7, then all four of them would have to be congruent. Okay, the first example says the diagonals of rhombus FGHJ intersect at K. Use the given information to find each measure. So the first thing I would look at here is, since this is a rhombus, I would go ahead and mark all four sides congruent. And then these are the things you're going to want to memorize, that the diagonals form a right angle. And they also bisect the angles. So let's go ahead and label our picture here. If the measure of angle FJH is 82, so that's this angle here. If it's 82, then we know that each part here is 41 because it's bisected. And then we want to find the measure of angle KHJ. So this is the one we're trying to find. And remember, if it forms one right angle, those lines, then they form four right angles. So to find this missing angle, I have a right triangle. So 41 plus 90 plus your missing angle, which we could call X, is equal to 180. And so when you solve that, you would get X to be 49. So the measure of angle KHJ is equal to 49. Okay, then the second part says if GH is X plus 9, so that's this side here, and JH is 5X minus 2, find X. And we know in a rhombus that all the sides are congruent, so we can just set those sides equal to each other. And then we're going to solve. Subtract X, and I get 4X. Add 2, and I get 11. Divide by 4, and X is 2.75. Okay, now, oh, it looks like this got cut off a little bit. This square, this sentence here got cut off, but it should be on your notes, and that is that a square is a parallelogram with four congruent sides and four congruent angles. So the best way to remember that is that it's a rectangle and it's a rhombus. So if a rectangle and a rhombus made a baby, you have a square. So this Venn diagram is giving you this concept, a picture of this concept. So you have your rectangles over here on the left, you have your rhombi over here on the right, and they're showing you those characteristics. A rectangle is four right angles, a rhombus has four congruent sides, and then if you look at a square, it's the combination of that, the four congruent sides and the four right angles. Okay, now this is if you're wanting to prove these theorems, if you're wanting to prove that quadrilaterals are rhombi or squares. This is doing the converse of what we already learned, and that is if the diagonals are perpendicular, then you can conclude it's a rhombus. If you know one diagonal bisects a pair of opposite angles, again, rhombus. And then this one would be a little bit newer, and it's just if you have a pair of consecutive sides, so that means sides that are next to each other. If those consecutive sides are congruent, then you can conclude that it's a rhombus. So if you look at this picture, AB and BC, if those are congruent, we can say it's a rhombus. Um, and then the last thing, if you can say something is both a rectangle and a rhombus, then you're going to call it a square.